A child is born somewhere in East Africa nearly 200,000 years ago. Their skin is dark. Their parents have dark skin. Their grandparents do too. In fact, every human alive at that time looks remarkably similar. Now, fast forward to today. Some people have skin as dark as polished ebony. Others have skin so light it burns after only a few minutes in the summer sun. Between those extremes exists an incredible range of colors found across every continent on Earth. So what happened? Did humans somehow become different species? Did nature simply decide to paint people in different colors? Or was there an invisible force quietly shaping our bodies for thousands of generations? The answer isn't hidden inside history books. It's written in sunlight. Every shade of human skin tells the story of an ancient journey, one that began under the blazing African sun and continued across frozen mountains, endless deserts, dense forests, and icy northern landscapes. But here's the strange part. For most of human history, there was no such thing as white or black in the way we think about race today. There were only humans, trying to survive wherever they happened to live, and their skin changed because survival demanded it. This isn't a story about race. It's a story about evolution. If you could travel back to the very beginning of our species, one thing would surprise you immediately. Modern humans didn't appear across the world all at once. The oldest evidence tells us that our species first evolved in Africa. For tens of thousands of years, every human lived beneath some of the strongest sunlight on Earth. The African sun is beautiful, but it is also relentless. Every single day, invisible ultraviolet radiation, better known as UV rays, poured down from the sky. Unlike heat, UV light cannot be seen. You don't feel it touching your skin. Yet over time, it has the power to damage cells, destroy important nutrients inside the body, and increase the risk of disease. If our ancestors had remained unprotected, surviving generation after generation under that intense sunlight would have been incredibly difficult. Nature needed a solution, and evolution found one. That solution was melanin. Melanin is the natural pigment that gives color to human skin, hair, and eyes. But its real purpose has nothing to do with appearance. Melanin is a shield. Think of it as millions of tiny umbrellas inside your skin. When harmful UV rays strike your body, melanin absorbs much of that energy before it can cause serious damage. The more melanin you have, the stronger that natural protection becomes. This is why the earliest humans almost certainly had dark skin. It wasn't about beauty. It wasn't about identity. It wasn't even about choice. It was biology solving a problem. Those whose skin offered better protection were more likely to stay healthy, have children, and pass those helpful genes to the next generation. Generation after generation, dark skin became one of humanity's greatest survival tools. But protecting skin wasn't the only challenge. Deep inside the human body is a vitamin called folate. Most people rarely think about it today. Yet thousands of years ago, it was essential for survival. Folate plays a major role in healthy cell growth and successful pregnancies. Without enough of it, serious health problems can appear, especially in developing babies. Strong UV radiation can gradually break down folate inside the body. In regions with intense sunlight, losing too much folate could reduce the chances of healthy children being born. Dark skin acted like a natural defense system. By blocking much of the damaging UV radiation, it helped protect one of the body's most valuable resources. Without knowing it, evolution wasn't simply protecting skin, it was protecting future generations. For a very long time, this solution worked perfectly. Africa provided food, water, animals to hunt, plants to gather. Human communities adapted to their environment, and their bodies reflected the world around them. But humans possess one remarkable quality. Unlike almost any other animal, we explore. Curiosity pushed small groups farther and farther away from familiar lands. Some followed migrating animals, others searched for new rivers. Some were forced to leave because climates changed. Whatever the reason, tiny groups eventually began leaving Africa. They didn't know they were beginning one of the greatest migrations in history. They simply kept walking. Those journeys took thousands of years. Families crossed deserts, moved along coastlines, climbed mountain ranges, entered forests they had never seen before. Each generation traveled only a little farther than the last. No one realized they were slowly spreading across an entire planet. As they moved north into parts of Europe and Asia, something unexpected happened. The world itself began changing. The days became colder, winters lasted longer, clouds covered the sky more often, and perhaps most importantly, the sunlight became weaker. Not because the sun had changed, but because the angle at which sunlight reached Earth was completely different. The farther people traveled from the equator, the less powerful the UV radiation became. The same skin that had been a huge advantage in Africa now faced an entirely new environment. At first, nothing seemed wrong. People still hunted, still built shelters, still raised families. But over many generations, another hidden problem slowly appeared. The human body depends on sunlight to produce vitamin D. Unlike most vitamins, vitamin D isn't found in large amounts naturally inside us. Our skin actually helps make it when UV rays touch the body. In Africa, where sunlight was intense throughout much of the year, this happened easily. But in colder northern regions, sunlight was weaker. Winters were longer. Heavy clothing covered most of the body. People spent more time inside shelters to escape freezing temperatures. Suddenly, producing enough vitamin D became much harder, and without enough vitamin D, bones become weaker. Children may not grow properly. Adults become more vulnerable to illness. Once again, evolution faced a new challenge. The solution that had protected humans in Africa was no longer perfect in the north. Nature rarely creates bodies that are perfect everywhere. Instead, it creates bodies that are best suited for the place where they live. And over thousands of years, that ancient balance between protecting against too much sunlight and absorbing enough of it would completely reshape the appearance of millions of people. What seemed like a simple difference in skin color was actually one of evolution's greatest survival strategies. And this was only the beginning, because the farther humans traveled across the planet, the more surprising their evolution became. The farther humans traveled from Africa, the more complicated the story became. Many people imagine evolution as something that happens overnight, as if one generation woke up looking completely different from the last. But evolution doesn't work like that. It doesn't have a goal, it doesn't make plans, and it certainly doesn't decide what humans should look like. Instead, it quietly rewards whatever helps a population survive. Imagine spilling a single drop of blue ink into a river. At first, nothing seems different, but mile after mile, the water slowly changes. Evolution works in much the same way. One tiny genetic change appears. If that change helps people survive, it becomes a little more common in the next generation, then a little more common again. After thousands of years, the population begins to look different, not because evolution wanted change, but because survival slowly reshaped humanity. As groups settled in different parts of the world, every environment began writing its own chapter of human history. Northern Europe was cold, cloudy, and received far less sunlight than Africa. People who naturally produced slightly less melanin could absorb more ultraviolet light through their skin. That meant their bodies were often better at producing vitamin D. It wasn't a dramatic advantage overnight, but over hundreds of generations, even small advantages matter. Children with stronger bones were more likely to survive. Healthy adults were more likely to raise families. And slowly, genes linked to lighter skin became increasingly common. Nature wasn't trying to make people look different. It was simply solving a new survival problem. But here's where the story becomes far more interesting. If less sunlight creates lighter skin, then why didn't every northern population become equally pale? The answer is surprisingly simple, because sunlight wasn't the only thing affecting evolution. Food mattered too. Take the Inuit people living in the Arctic. They spent thousands of years in one of the darkest environments on Earth. By the simple sunlight theory, they should have evolved extremely light skin. But they didn't. Why? Because their traditional diet was rich in fish and marine animals. Those foods naturally contain high amounts of vitamin D. Unlike farming communities in Europe, the Inuit didn't depend entirely on sunlight to get this essential nutrient. Their food solved part of the problem, so evolution had far less pressure to dramatically reduce melanin. One simple difference in diet changed the direction of human evolution. Now travel to another side of the world, Australia. The ancestors of Aboriginal Australians arrived there tens of thousands of years ago. Unlike Europe, Australia receives intense sunlight across much of the continent. Generation after generation lived beneath powerful UV radiation, very similar to the conditions their African ancestors experienced. Because the environment remained similar, darker skin continued providing an important survival advantage. There was little reason for evolution to make dramatic changes. The same protective shield that worked in Africa still worked in Australia. Different continent, different people, the same sunlight, the same evolutionary solution. Asia tells an even more fascinating story. Asia is enormous. Frozen Siberia, tropical jungles, high mountain plateaus, open grasslands. No single skin color could possibly fit every environment. As humans spread across the continent, different populations adapted in different ways. Some evolved lighter skin, others remained much darker. And interestingly, scientists have discovered that Europeans and many East Asians didn't even become lighter through exactly the same genetic changes. Both populations reached a similar result, but evolution followed different paths. It's one of the strongest reminders that nature doesn't always find just one answer. Sometimes it solves the same problem more than once. Then something unexpected happened. Around 12,000 years ago, humanity changed forever. For hundreds of thousands of years, people survived mainly by hunting animals and gathering wild plants. Then agriculture appeared. Instead of constantly moving, communities began farming. Villages became towns. Towns became cities. At first glance, farming seems completely unrelated to skin color, but in reality, it changed everything. Early farmers often relied heavily on grains. Compared to the diets of hunters, these foods contained much less vitamin D. Suddenly, many farming populations depended even more on sunlight to meet their nutritional needs. In places where sunlight was already limited, this created stronger evolutionary pressure for lighter skin. Once again, the environment changed. Human biology responded. This is one of the biggest lessons evolution teaches us. There is no such thing as a perfect human body. Every adaptation involves trade-offs. Dark skin provides outstanding protection against intense sunlight. Lighter skin makes producing vitamin D easier in regions with weak sunlight. Neither is better, neither is worse. Each evolved because it helped people survive in a particular place at a particular time. Skin color isn't a ranking, it's a record of ancient environments written into our DNA. And yet, even after thousands of years of adaptation, evolution wasn't finished because humans were about to do something they had never done before. They began crossing oceans, building empires, connecting continents. People who had evolved separately for tens of thousands of years suddenly started meeting again. And when those populations mixed, human history entered an entirely new chapter. The incredible diversity we see today is the result of those ancient journeys finally coming back together. The incredible diversity we see today is the result of those ancient journeys finally coming back together. For thousands of years, different human populations lived largely separated from one another. Mountains, deserts, oceans, and vast forests kept people apart. Each group continued adapting to its own environment, generation after generation. But history never stands still. As humans learned to build ships, create trade routes, and establish civilizations, those isolated worlds slowly began connecting again. People traveled farther than ever before. They traded ideas, languages, technologies, and eventually, they formed families together. The boundaries that had once separated human populations slowly disappeared. Today, millions of people carry genetic ancestry from multiple continents. Our DNA has become a living record of thousands of years of migration. Yet despite all this mixing, one myth continues to survive. Many people still believe skin color defines different kinds of humans. Science tells a completely different story. Every person alive today belongs to the same species. The genetic difference between two people with completely different skin colors is incredibly small. In fact, humans share more than 99.9% of their DNA with one another. That tiny fraction of variation creates differences in skin, hair, eye color, and other physical traits. But underneath, every human body works almost exactly the same. The same heart, the same bones, the same organs, the same brain, The same evolutionary history. Skin color may be the first thing we notice, but genetically, it represents only a very small part of who we are. Modern science has also revealed something fascinating. Skin color isn't controlled by a single gene. It's influenced by many different genes working together. Some affect how much melanin your body produces. Others influence how that pigment is distributed throughout the skin. That's why human skin exists on a continuous spectrum rather than fitting into neat categories. There are countless shades between the darkest and the lightest skin. Nature rarely creates perfect boxes. Instead, it creates gradual variation, and that's exactly what we see across humanity today. Another surprising fact is that evolution never actually stopped. Many people think evolution belongs only to the distant past, dinosaurs, cavemen, ice ages. But evolution is happening right now, very slowly, across countless generations. As environments change, as diets change, as diseases appear, human populations continue adapting. Not in dramatic ways we notice overnight, but through tiny genetic shifts that accumulate over time. The story of human evolution is still being written. We're simply living in the middle of it. Climate is only one piece of that story. Culture has become another powerful force. Thousands of years ago, surviving winter depended almost entirely on biology. Today, we wear warm clothes, build heated homes, travel by airplane, use sunscreen, take vitamin supplements. Our inventions now solve many of the problems that evolution once solved alone. In other words, technology has changed the rules. The environment still affects us, but human intelligence has become one of our greatest survival tools. Sometimes, instead of changing our bodies, we change the world around us. Perhaps that's what makes our species so unique. Other animals mostly adapt through biology. Humans adapt through biology and imagination. We invent, we build, we learn, we pass knowledge from one generation to the next. The same curiosity that led ancient humans to control fire eventually led us to medicine, science, satellites, and space exploration. Our greatest evolutionary advantage was never just our bodies. It was our ability to think. When we look at human skin today, it's easy to focus only on appearance, but every shade tells a story. Dark skin speaks of ancestors who lived beneath powerful tropical sunlight. Lighter skin reflects generations adapting to colder regions with weaker UV radiation. Olive skin, golden skin, brown skin. Every variation carries the fingerprints of ancient environments. None of them appeared by accident. Each one represents thousands of years of survival. Nature wasn't creating beauty standards. It was solving biological challenges. Imagine standing beside your ancestors tens of thousands of years ago. They had no idea what DNA was. They knew nothing about melanin, nothing about ultraviolet radiation, nothing about vitamin D. Yet with every generation, evolution quietly kept working. Without speeches, without instructions, without anyone noticing. Tiny genetic changes passed from parents to children, year after year, century after century, until eventually, the people living in different corners of the world began looking different, not because they stopped being human, but because they never stopped adapting. So, why did ancient humans change skin color? Not because one color was better than another, not because different groups became different species, and certainly not because nature was trying to create divisions. Human skin changed because the world changed. Different climates demanded different solutions. Strong sunlight rewarded protection. Weak sunlight rewarded efficiency. Evolution simply responded to the environment. What we see today isn't a collection of separate human stories. It's one continuous journey that began in Africa and spread across every continent on Earth. Every shade of skin is a chapter in that journey, a reminder that all of us, no matter where we come from, share the same ancient origin, because long before borders, long before civilizations, and long before history was ever written, we were all part of the same family. And perhaps that's the most remarkable discovery of all.